Welcome back to the deep dive. Today, we are getting our hands dirty. Literally, we are heading into the garden.
But maybe not in the way you'd expect.
No, not at all. We're talking about this absolute obsession with fermentation that seems to be everywhere right now.
Oh, it really is. I mean, you can't look anywhere without seeing, kombucha sourdough starters.
Exactly. And our story today starts with two students, Kesser and Steen, who are deep in that world. They're in a nature and innovation class, and they are, by all accounts, total fermentation nerds.
They love the concept, the idea that you can take waste and with a little biology turn it into something valuable. It's like biological alchemy.
Right, but then they get thrown a massive curveball. They run into this super enthusiastic gardener. Let's call her Tante Grün, Aunt Green.
And she's found a life hack on social media.
She has. She comes to them all excited and says, look, I'm taking the wood ash from my stove, adding sugar, and fermenting it into a super fertilizer.
That's where the record scratches for the students.
Totally, because on one hand, they want to believe it. Ash has nutrients, right? Fermentation is good. But something about the chemistry is just screaming no.
Yeah, their scientific brains are blinking red.
So our mission today is to unpack their whole investigation. We're going to dig into the chemistry of fire, the biology of wood, and try to answer the big question, can you actually ferment a bonfire?
It's such a great case study. It's internet hype versus molecular reality. And to really get why Kesser and Steen were so skeptical, we have to start way before the ash even gets into the bucket.
With the wood itself.
With the wood. This was a huge eye-opener for me in their notes. We think of wood as just wood, but it's not one uniform thing.
Right. They make this really clear distinction between the trunk of the tree and something they call ramial wood.
Ramial wood. Yeah, it sounds technical, but it's simple. It's just the smaller branches, twigs, buds, anything less than, say, 7 centimeters thick.
The active parts of the tree.
Exactly. That's where the life is. The sap is flowing, the leaves are growing. That's the tree's engine room. So that wood is packed with everything a plant needs to grow. Nitrogen, phosphorus, potassium.
Okay, so that's the twigs. What about the trunk, the big logs?
Well, the trunk is structural. It's the skeleton. Its main job is just to hold the tree up.
So it's more like rebar.
It's heavily calcified, yeah. The calcium is locked into the cell walls to make them rigid. So you burn a big oak log, you're mostly burning calcium. You burn a pile of twigs, and you're burning a whole nutrient packet.
Okay, so the source material is critical, but then Tante Grün doesn't just grind it up, she burns it in a stove.
And the fire changes everything. This is the heat factor. It's the variable that almost everyone with a garden hack forgets.
She's just trying to heat her house. She's not running a lab.
Right, so she has a roaring fire. We're talking really high temperatures, maybe 600, 700, 800 degrees Celsius.
And at that heat, what happens?
You drive off everything volatile, the carbon goes up the chimney as CO2, and crucially, the nitrogen, the thing plants need for green growth, it just turns into gas and disappears.
So the nitrogen's completely gone.
Gone. What's left are the minerals, but they're in their oxide forms. Calcium oxide, potassium oxide.
Oxides. Okay, chemistry class flashback. What's important about an oxide?
They're reactive, very reactive. When calcium oxide hits water, it doesn't just, dissolve. It reacts pretty violently to become calcium hydroxide.
Which is lye.
It's lye, a strong base. And this is the absolute core of the paradox. Tante Grün has this bucket of ash, which is just dormant lye, and she dumps it in water.
And Kesser and Steen actually tested this.
They did. They measured the pH. It's between 9 and 10.
Which is really, really high for anything biological.
It's astronomical. Remember, the pH scale is logarithmic. A pH of 10 is 1,000 times more alkaline than neutral water. It's caustic. It's chemically in the same family as oven cleaner.
Yikes. Okay, so she's got a bucket of what is essentially week of oven cleaner. And then she adds sugar to ferment it.
And this is where the students who love fermentation just facepalm, because they know what fermentation is. It's not magic, it's biology.
It's microbes eating sugar.
It's living things like yeast or bacteria consuming sugar and making byproducts, usually acids or alcohol. But they are living things. They have cell membranes.
And what happens when you drop a living cell into a pH 10 solution?
It dissolves. The lye basically turns the fats in the cell membrane into soap. It's called saponification. It creates a completely sterile environment.
The soap analogy in their notes was brilliant.
It was, because that's how people made soap for centuries, right? You mix lye from wood ash with animal fat.
And you get soap. So the students ask,
Who tries to ferment soap?
it's such a great question. You can't. Soap is literally what we use to kill bacteria.
Exactly. You've created a kill zone. So when Tante Grun adds her sugar, there's nothing alive in there to eat it.
The microbes are dead on arrival, so the
Yeah.
sugar just sits there.
It just sits there. It might break down a bit chemically because of the high pH, but it is absolutely not fermenting. There's no biology happening. It's a ghost town in a bucket.
Okay, but I have to play devil's advocate for Tante Grun here. The notes say that if you leave the bucket for a few weeks, the pH does drop.
It does, and this is the most deceptive part of the myth.
Right, because she sees that and thinks it's working, it's fermenting, it's becoming acidic.
But it's not biology, it's just the air.
The air.
Carbon dioxide. CO2 from the atmosphere slowly dissolves into the water, and CO2 plus water makes a very weak acid, carbonic acid.
Ah, I see. And acid neutralizes a base.
Exactly. The weak carbonic acid reacts with the strong calcium hydroxide, the lye, and turns it into calcium carbonate, which is basically chalk. The solution is just going stale. It's simple, inorganic chemistry.
So it's not becoming alive, it's just becoming dead in a different way.
It's chemistry, not biology. It's losing its punch. No microbes required.
And they proved this with that eggshell comparison, which I thought was really smart.
That was the nail in the coffin. They
Oh.
took eggshells, calcium carbonate, a base. They put some in real fermented herb juice.
Which is actually fermented, so it's acidic.
Yes. And the acid attacked the eggshells. They fizzed, they dissolved, the nutrients were released,
And the other batch of eggshells went into the ash water.
and nothing.
Oh.
Crickets. Because you're putting a base, the eggshell, into another base, the lye. They just sit there
Yeah.
staring at each other. The base wins.
So she's not releasing nutrients, she's actually locking them up in this hostile chemical environment.
She is. So, okay, we've debunked the fermentation. It's just sweet, stale lye. The big question is, if she pours this on her garden, what happens?
To her prized tomatoes.
Best case, not much. Worst case, she gives them a chemical burn.
On the roots.
Yeah, roots are incredibly sensitive. They're designed for soil, which is buffered and complex. You hit them with a shot of pH 10 liquid, and you can strip their protective layers. You can shock the whole plant.
And the ultimate irony, as the students pointed out, is that the one thing the plants really need, nitrogen.
Is gone. It went up the chimney. So she's risking her plant's health to feed them a fertilizer with zero nitrogen. It's all out of balance.
So Kesser and Steen have done the science. They know the hack is a bust. But they can't just go to Tante Grun and say, you're wrong. They need a better way.
And I love how practical they are here. They offer a few paths. Path 1 is for the diehards who just want to use the liquid.
What's the advice there?
Treat it like a chemical reagent.
Yeah.
Don't think of it as food. Think of it as a pH adjuster. If you have another liquid feed that's too acidic, you can add a tiny drop of ash water to balance it, but very carefully.
Okay. Path 2.
Path 2 is just, wait, let the bucket sit for months until the air neutralizes it completely. But, I mean, you're just left with messy sludge. It's not really worth it.
Which leaves us with path 3, the winner.
The winner. Keep it solid. Do not add water. Do not add sugar.
Just use the dry ash.
Yes, sprinkle it very, very lightly in your compost pile, or directly on the soil in tiny amounts.
Why is dry so much better?
Because you let the soil do the chemistry. When you add dry ash to compost, the moisture and all the organic acids in the pile buffer that high pH slowly. The microbes, the worms, they mix it in. It becomes a slow-release mineral supplement.
So you go from a chemical shock to a gentle trickle.
Precisely.
Okay.
But then they go one step further, and this is the innovation part of their class. They suggest Tante Grun is solving the wrong problem.
The problem isn't the ash.
The problem is, why are you burning all those nutrients in the first place?
This goes back to the ramial wood,
That's-
twigs and branches.
Yes. Their advice is brilliant. Burn the big logs for heat, that's fine. But those nutrient-rich branches, don't put them in the stove.
Get them.
Chip them. Make wood chips. Put them directly under your fruit trees as a mulch.
And this brings it all back to their love of fermentation.
It does. This is their big insight. Tante Grun is trying to force a fast, hot fermentation in a plastic bucket. But by putting wood chips on the soil, she could start a cold fermentation.
Cold fermentation. I like the sound of that.
It's just decomposition, really. But it's driven by fungi. White rot fungi move into those wood chips, and there are masters at breaking down wood. As they eat the wood, they slowly release all those nutrients right where the plant roots can find them.
So it's fermentation on nature's timeline.
Exactly. And unlike the ash bucket, the wood chips build soil structure. They create humus, they hold water, they feed worms. You're building a sponge, not just adding a liquid.
They even had that great hack for people without a chipper.
The lawnmower hack. I
Yeah.
love it. So simple. Got hedge trimmings. Just run them over with a lawnmower a few times.
It creates a perfect mulch.
It does. It chops up the greens and the browns, the nitrogen and the carbon. It's a perfect meal for soil life. No sugar needed.
It's like their whole journey went from how do we ferment ash to, wait, the soil is already fermenting everything for us.
That's the whole lesson. Tante Grun was trying to play chemist in a bucket. But the soil is a much, much better chemist than we'll ever be.
It's forcing a result versus facilitating a process.
You said it perfectly. Fermenting ash is a contradiction in terms, but you can ferment the wood before you burn it. You just call it composting.
And we're impatient. We want the life hack, the 3-minute video that shows a bubbling bucket.
We do. We see bubbles and think science. We see a quiet pile of wood chips and think nothing's happening. But all the complex, amazing biology is in the pile. The bucket is a dead end.
So the final advice for Tante Grown, the elevator pitch.
I think it's, we love your enthusiasm, but put the sugar away. Feed the soil, not the plant. Chip your branches, compost your ash, and let the fungi do the work.
And maybe, just maybe, stop trying to ferment drain cleaner.
That's generally good advice for life, I think.
It's funny, though, this idea went viral for a reason. We have this deep-seated desire to turn waste into value.
It's a noble instinct. And there is value in ash. The mistake is just in the method. It's a reminder that our intuition is a great starting point, but sometimes you have to check the chemistry.
And the students showed that if you respect the rules, that lie is a base and fermentation needs life, you can find a real solution.
It just happens to be a lawnmower instead of a bucket. And frankly, it's a lot less work.
So for everyone listening, whether you have a wood stove or just a jar of kimchi on the counter, take a page from Kesser and Steen. Stay curious. But remember that real innovation isn't about outsmarting nature.
No, it's about understanding the systems that are already there, working perfectly. The most advanced technology isn't in the bucket. It's in the soil, waiting to turn sticks into apples.
If we stop trying to be the mad scientist, we might realize the lab is already running just fine without us.
We just need to give it the right ingredients and get out of the way.
Thanks for joining us on this deep dive. Keep composting, keep questioning, and please keep the lie out of your fermentation jars. We'll see you next time.